In this video, you'll be learning how a power amplifier works. You can see this is Preamp P5000X. So you can see it very simple. It's a very good amp. So what I will be doing is I will be breaking down the mode of operation. This is really applicable to any type of amplifier you are dealing with, irrespective of the product. The mode of operation are very similar, although there are some little differences, but they are similar. Alright, so if this sounds like something that really interests you, let's dive in. Okay, the first thing to really understand as a beginner or someone that really starts, amplifier, what they simply do is to amplify the signal coming. So let's say you make something from your from your mixer. Your mixer cannot power up your speakers, so they are the one doing the work. So the capacity of the amplifier will determine how well to drive that sound. So that's why it's very important. So let's now look at it. How does it now work? Very simple. You can see this is the major AC plug. You can see this is the part connected to your AC. So the voltage will come in through this place. If it comes in, you can see the wire where the voltage. Let me lock this. I'm coming. Let me lock the focus of my camera. Okay, so you can see the wire. This is where it comes in through. So if there is any fault with the wire, definitely your pump will not power on. So that's the first thing to check. So the AC cable coming through this place, there is a fuse here. You can see it fuse. So if this fuse is faulty, definitely it will not power on. So you can see, if you look at this place now, you can see the wire. It has the neutral, the live, and the head. You can see this yellow is it's always the head. Sorry for my camera quality, just manage for now. Alright, so you can see there, this is the head. You understand? This is the live signal, this is the neutral there. You understand? AC. Okay, so look at the head. It's always connected to the body of the amplifier, so it serves like the ground too. You understand? So if you see my live signal now, not signal rather, the live connection, you can see it here connected to this fuse, and from the fuse, this is the output of the fuse. Yeah, inside, let me come again. Inside this wire, there are 3 pieces of wire inside. You understand? One is the live, which is this red one. This is the neutral, while the third one is the head, or you call it ground. So it's always connected to the body for you to have a complete grounding. So you can see the live now. You can see it being connected to the fuse, and through the fuse it will now be sent out. So this is our blue, this is our red. So immediately it passed through this fuse, it changed to red color there. So if you trace it further now, if you see this line now, let's go. This blue line now, this blue line I'm holding is the one being sent to this black you are seeing at the front now. So definitely this blue has now changed to black in the front. Then this brown is now red now from the output of the fuse, which you are seeing here. Okay, so if you trace that line, you see that the black is our neutral now. This is our live signal. It has passed through the fuse, so if there is any problem, ordinarily the fuse, you cut it off. You understand? So that is the first thing to note whenever you have issue in amp. First check, is your cable good? That's the first thing to check. If the problem is not from your cable, check the fuse. Just lose this one out. There is a fuse inside. Read the continuity. Is it still good? If it is good, then there is not a problem. Then continue. If you trace it further now, you see that this is the black now. Now it's coming up to my switch level. You can see it to the switch now. And getting to the switch, this is a two-way switch if you look at it properly, and this one has the ability to handle the live and the neutral separately, unlike some other switch that you can only run just one line straight. So this is the what's it so called? Okay, let me show you the neutral. Okay, this is the neutral now. You can see the neutral being connected to the transformer. So what happened is, through the live side of it, so this is it connected to this. So this one, sorry for the confusion above, the way normal switch work is just for you to cut a line. Let's say 2 wire are going, just pick one, cut it halfway. So the black one, which is the neutral here, is the one going here. You can see it here. which I'm holding. So it's coming straight here, and if you trace it further, see that it's connected to the transformer. So that signal is going straight to the transformer. Then the life, which is this one, now comes in through the switch while it continues straight to the transformer. So you can see the two legs now, they are the one being connected to the transformer. So this is the primary side of the transformer. I believe that is very, very clear now. So AC input, once your cable is now having issue, check your fuse. If it is not having issue too, then your transformer. So there's a way to operate, then straight to the transformer. So what the transformer does is the normal voltage, depending on your country. For a country like mine, it will use 220. Some other places use 110, whatever the one you use in your country, just know it, you understand. So if you look at the rating of this transformer, come on, let me show you clearly. You can see this black, they are trying to tell you that this primary side, that is this black that we have here, you know, is the one being connected to our AC input now, you understand, what is coming straight from your cord. So this is it. You see, one goes through the switch, the other out, then the other one straight. Okay, so that is what they're trying to say here, that the black symbolize the AC voltage, that is the primary side, which this is meant for 220 volts. Now for the output side, now this is the secondary side. Now you can see we have different tongues. We have 014, that's red, we have 48.0, that is blue, black, okay, that is 48.048, that is blue, black, blue. That is for this signal. Where's the so-called? Okay, this one. You can see this is the secondary side. So we have a lot of output from this transformer. So for this blue, black, blue now, that is this blue. This is blue. It's 48 volts. This other one is 48 volts. While this is the ground, which is the ground here, it is 0. You understand? So this is 48, 0. If you don't understand the reason why for that, I've done a lot of video on amplifier building, so you can watch that, because a normal amplifier will always need the positive voltage and the negative. So by the time you pass through your capacitor output, you'll be having plus 48, minus 48. Okay, we'll still get that later. Alright, now so that is for the 48.048 now. And the other one is 17.017, that is yellow, black, yellow. So look at it here now. So for this signal on this particular output, the secondary side, so this one is carrying 17 volt, this one is carrying 17, while this one is the black, which is the neutral there. Do you understand? Then the last one, which is red, that is red, that is 014. So red, as you can see there. Image, okay, it should be clear now. So this is the red there now. So one of it is 0, the other is what is so called? Sorry, the other one is 0, the other one is 14. Okay, so just note this is the secondary side. Don't do mistake of plugging this one to the AC. You burn this transformer instantly. So this is the primary side, which picks up the voltage coming in. This one will be the one to send out. Okay, so I want to understand that through AC cord to the switch to the transformer, then being sent to the output side. Now the next stage all this various secondary voltage will pass through is to move to what we call your rectifier. Now if you look closely here, let me turn this. Okay, just manage, you know, they are not having issue, that's why I don't need to distort it. If not, I would have closed it for you to see, but don't worry, I still have a lot of video where we'll build amplifier from scratch, so you understand it better. So that's the reason why you must like this video, subscribe so you don't miss out when I drop that video. Okay, so from now let's deal with this first one, which is 48.0. Now this is our ground. We don't necessarily need it for this rectifier. Now for a normal rectifier has 4 tongues, you understand. We have the AC, one side will be plus, one side will be negative, you understand. So what will happen is the side that is the AC, now because this transformer is still in AC mode, it's still in AC mode, so the AC that comes in was 220, then what is coming out is being splitted into different voltage, 48, 0, 17, 0, 14. Okay, so what this guy needs to now do, because the major amp here, which is the preamp and the amplification stage here, they make use of that 48, the high volt there, you understand? So what this guy will now do is, this is still in AC mode, it will now step down the AC, you understand, to DC. You understand? Because we can, all these components cannot really work with DC. And with AC, they only work with DC. So this guy will convert it from AC to DC. Okay. Maybe in my next video I will show you what a diode looks like. But if you look at this pin out of this one, okay, there ought to be one here, yes, which they skip the process. So you can see this side is plus, the other side is negative, then the middle is AC. So for this one now, it's this capacitor that is blocking us. So same thing is applicable to this side. You can see the minus at this side, the plus is at the other side here too. If you check it well, you can see it. So the middle two leg are the AC. So that is where these two guys are connected to. Okay, so immediately it comes out, then we have a negative voltage. So that your 48 will now change to minus 48 plus 48. Then you now pass through all these various capacitors, so to make the voltage more stable and to make it, you understand what I mean? So by the time you get to this stage now, don't be surprised that your 40 volt or 48 volt will now may likely change to 60, sometimes more than, you understand? So the reason for that is to make it more stable, because by the time you are drawing more power in the process of you amplifying, you know, the voltage needs to be very, very stable. So that's the reason for that. So it will pass through this place, then each segment will pick up their various voltage. Don't worry, by the time I show you how to build it from scratch, you will really understand better. So first thing to check, which is very, very common, transformer fault. If the transformer is not having issue, check your rectifier diode, you understand? If it is not having issue, most time it should be the one. If it is power issue, you understand, then this is capacitor. In case you see any swollen one or any blown one, replace it immediately. Now for this side, this ours is a yellow, is 17, 17017. This side, this is his own diode, you understand, because the voltage is not as large as the one here. So that's why we can use a small one here. Then the capacitor will make it stable. Then these are some 7805. These are voltage regulators, so they will help us in stepping down the voltage to some, you know, the part. There are some part that need just 5 volts, some need 12. So they will do the basic rectification. This is what we call a relay. Now this one helps us in speaker protection. So if there is any problem, you can easily cut it off, and the rest. I know there are a lot of wires. It's easy to get confused. Don't worry. We'll still build one from scratch and you understand. So this is our preamp board here. This is the preamp board. What this does is the signal coming. This one will amplify it a bit. Then the capacitor, the transistors here, will now add some wattage to it to increase its ability, because this preamp itself are not that really powerful. You understand? Let's say the preamp supplies 200 watts now. By the time, because each of this guy can really supply up to 250 watts. So by the time you combine all their various watts together, then this board will be more powerful, because let's say 250, this 750, the other side that is 15 already, you understand? So by the time you add it to the capacity of this, is already giving us 2000 watts, you understand, which is very, very more better compared to when you don't have all this. So that is why we have the preamp board. Okay, these are what we call it choke sometimes, and some people call it concrete resistor. We have different type of it. There are some, if you watch my previous video, there are some like squares, rectangular shape like this, not directly flat like this one, but they are still doing the same function. It's usually 5 watts, 0.33 ohms joules. Okay, so if there is any problem on this one, just check for it and you'll be able to trace it out. Then on this preamp board there will be a section for input. You can see this is our input here. This is input. So the input will come here, because your major input will come through the back. What is coming out from your mixer will come here. Then from there to come to your volume, then it will send here. But you know what, let's just cut this video up so that it will not be too long. I will be doing some various work on this amp, so I'll be breaking it into section. So but in basic, to keep it very simple, that's just how an amplifier works, which is very simple. AC outlet to your transformer, you understand, the primary side of the transformer, from your primary side to your secondary side, from your secondary side to your rectifier, from your rectifier to your capacitor to make more stable. Then from your capacitor, each of the side of the amp can now pick their own various voltage. So let's say 50 volts comes out from this. Now this will pick his own ground from it. It will pick it plus 50 and minus 50, because we have the NPN transistor and the PNP. Then this side will do its own, so they are both sharing. If you look at it here now, you can see it. You can see this is plus VL, so this is the plus voltage now. So this plus, now if you see one side is going here, then the other side is coming here. You understand? This is the negative side coming here. So that's the way they will share. So they are both sharing the power here. So that's why the voltage must be really stable, and the capacitance. Yeah, alright. This video has really helped you to understand as a beginner or intermediate, and you've gotten some value here. To like, subscribe for more helpful videos like this. See you guys in my next video. Peace. Thank you.